There's a lot of cool products on display here. Can you mention some of them?
We have linear motion, we have safety, we have visual inspection with cameras, we have robotics, and we have HMI. Everything is being run on one controller.
Should we try to make a deep dive into the machine?
Yeah, let's do that.
We innovate, we elevate. We are automates.
Oh, Sverre, I already spotted some really interesting stuff.
You know, I have a weak heart for stepper motors.
I spy with my little eyes some M12 connectors.
Yes, now we have launched stepper motors with M12 fast connectors, so it's much easier to install and mount these new motors. You can see there's one power connector and one feedback connector.
So Sverre, I see the wires are going down here. Is it some really special big motor controller controlling this stepper drive?
No, it's wireless. No, of course not. It wouldn't work in an industrial environment. It's one of our X20 modules. You can see here number 1, 2, 3, 4 from the left.
X2.
X2 module. So we actually have two motor channels here. So one is up here and another one is for another motor over here.
So this drive here can just run on the bus as all the I/O modules on it, connected to a PLC or a bus controller here. So it's really easy to mount.
Yeah, and you could just plug in as many as you like.
Yeah, and how about the voltage?
The voltage, it goes up to 58 volts, I mean. Perhaps I should have been reading up on that part. In that range.
Now we can just take one micro step further, then we can look at something else that's really cool to see.
Yes.
The ACOPOS 6D, we can see there are some different segment sizes here.
Yeah, it's almost magic. It's hovering in the air.
Yeah.
And this is actually quite a cool use case because for sure you can use it as a transportation layer, just as more or less as an advanced conveyor. But you can also do other stuff like rotating in a specific position. As here you do some sort of inspection, height control, and you turn slowly the shuttle to the position of each of these glass bottles.
Yeah, so normally if you just have a static conveyor built, you would often have some kind of robot to make it dynamic to fit the products that are being processed. But here you can turn it upside down. So here you have all the dynamics down here in the ACOPOS 6D system. So the top system don't really have to be dynamical. It can just be a simple linear gantry like this.
Do you want to take another step into the future?
We can take a micro step further.
Yes. Yeah, we have the camera. And here you see a visual inspection of these glass bottles in this use case. And the idea is that you have a static camera. Instead of having several cameras in different positions and orientations, you have one static camera and then you just twist and turn the product. So you can inspect all the bottles in one fixture.
And here you can also see one of the big benefits that we were mentioning before, that there's one controller here for the whole system. So that also means that all the things are in the same time zone here. So it's really easy to take a picture at the exact time when you want it, because you know exactly the orientation of the shuttle here, so you can take the picture immediately when you want it.
Yeah, there's no physical signal exchange between the 6D system and the camera. It's pure software and the same CPU. If you come over here, you can actually see that there are different segment sizes.
Yeah, so in the past we only had the square ones. Now there is different kind of sizes, so you can easily fit it into the application that you want to do, how it can best fit depending on the process that are being done.
In the end, it's a matter of cost. How can we optimize the surface area of a segment in the best way?
And another thing you can see here, there is just a simple conveyor here transporting the shuttles. That means that you can mix these things. So you only have the segments here where you need the dynamics in the system, and where it's just pure transportation, you would just use a shuttle like this, a conveyor shuttle, because it would be too expensive to make it with the segments here.
Yeah, it's a showcase of doing a simple transportation with over here it's a timing belt transporting, but it could be a conveyor belt or whatever. Do you know why we have two servo drives here?
No.
Two dual axis servo drives, so it's 4 axes you have here.
I think it has something to do with this one.
Yes, because the robot is also controlled with standard automation equipment, servo drives, PLCs and I/Os. So here we have a classic Scara robot, and it's also controlled by standard servo drives from B&R and the same I/Os like the rest of the machine, and everything runs in the same controller. So it's a uniform software environment. The kinematic model of the Scara robot is drag and drop in the configuration, so you just take it from the toolbox into your configuration, and then you have the Scara robot with all the limitations and working range and strokes that's predefined from factory.
And as we mentioned before here, you can really see this is the robot controllers here. It's just ordinary server drives that you could use for any other application, but you could also use it just to control the robot here. But that also means there's no really interfacing here. It's just running on the bus, the Ethernet PowerLink bus. There's no special safety system here. It's just the safety that we have over here that we can use for door switches and so on. And it can also be used here for the server drives to make sure that the robot is controlled in a safe manner.
So you don't need to hardwire any e-stop in and out like a traditional robot controller.
No.
It's just software signals. Now we're on the other side of the machine, and over here we have the APCs, which is the industrial PCs from B&R that controls the entire machine. An APC from B&R is just an industrial computer with automation runtime, so it acts exactly like a PLC. Whether it's a Gene Rail mount PLC or this APC system, it behaves in the same way, just much more powerful.
Here we can see the HMI, and it's a hygienic design here in the stainless steel, so you could use it in an environment where that has a benefit.
Typically pharma or food.
And here you can see the buttons here, the LED buttons are integrated.
Yeah, I think you can access these buttons through OPC UA.
Yes, you can. Either OPC UA or hardwired also.
Okay.
Both things can be possible to do. We also have the RFID that you could use to identify the operator here. They can log in and then control the machine.
Oh, and as an alternative to a password.
Exactly. And on the screen for this demo case here, we can see this map view widget here that is actually showing the movements of the shuttles on the machine live.
So this is an example of many different technologies you can control from one single PLC. And what are the benefits, Mads, of having just one CPU instead of having various different software environments?
The really big benefit is of course the timing of it. That's really nice to have all the same thing in the same timing zone. It's easy to combine the different technologies, the cameras, the movement, the robots, everything is in the same time zone. Another big benefit is of course software updates. So I don't really need to go on with my PC and update every single component here. It's all just in one environment, so I can make one update package and then it can update the whole system. The HMI, the PLC, the ACOPOS system, the vision, everything can be in this one package.
Actually just plug in one USB stick in here and then everything is updated.
Or it can come from the network, doesn't have to be USB.